Everybody, please, you know the signal. We will restart now with the last session, session E, Solutions Resilience. So please take your seats in this fantastic sunny place. While you are just taking your seats, I want to introduce the chairman of the last session of this conference, Karl Friedrich Ziegern, who is a scientist who has worked for a long time at KIT in science and also in science management. And before, he had also a history at Fraunhofer already, where he already worked on sustainable solutions together with industry, so those who know Fraunhofer. I must also mention that for over 10 years, then he was actually responsible for the division Built and Natural Environment that I direct now here at KIT. So he was my predecessor, and he actually established this division. And he was also fundamental in setting up the whole conference, because he's not just member of the organizing committee, but we could rely on his experience and insight in organizing this program. So it is not by chance that he will steer this last session. So please, Kafi, the floor is yours.
For this very nice introduction, and yes, I'm really keen to start this last session. We have already had yesterday and the day before yesterday two very interesting energy sessions which I could share, and I would like to start with the first presenter, with the first author. It's Frank Krysiak. I hope I pronounce you right. Frank is with the University of Basel. He is a professor in the Faculty of Business and Economics, and he holds the chair of Environmental Economics. And he will talk about the research for sustainable development, how economics influence the Swiss energy transition. So I'm very keen to learn about Swiss energy transition. Please, stage is yours.
So after listening to this very inspiring talk this morning, I would have used a different title. A much better title, and I hope I will be able to switch a bit to this, is how research made the Swiss energy transition more artful. And I will jump directly in. I think I have to talk a bit about energy transition in Switzerland because it's a bit different from what we see in Germany or many other European countries. I will briefly outline what's happening there. I will talk a bit about how research is organized for this transition, and then jump into two examples that we did in the research center that I was heading, and arrive at some conclusions. So, if I talk about the Swiss energy transition becoming more artful, this is a nice picture because it shows we are halfway. If I had known, I would have brought you the former picture, how it looked 10 years ago. 10 years ago, you would have seen a flow chart of energy. So totally technology-centered. Today, the Swiss energy transition is a transition where we look at technologies being placed in space, PV systems, hydrogen production. We're talking about a shift to electrical mobility, things like this. So it's kind of a complex picture that we have today. But I said it's halfway done if we want to become more artful. What you're not seeing here yet are human beings. So it's all about technology still. And I think this is something we as researchers have to change if we want to make this transition become successful. The problem that we face is a bit that it's a transition in a certain sense. So when we started working on this roughly 12 years ago, the Swiss energy transition was informed by Fukushima So it was really a transition that was looking at phasing out nuclear energy. It was an electricity-centered transition. There was no talk about heating systems or mobility at all. It was just electricity. And today we are looking at a transition that aims at achieving net zero in Switzerland, which is a totally different animal. So we are talking a lot about mobility, we are talking a lot about heating, we are still talking a lot about electricity, but not in the sense of phasing out nuclear, replacing nuclear by renewables, but in the sense of producing much, much more electricity, because we will have heat pumps, we will have electrical vehicles, we will need twice the amount of electricity that nuclear energy is still supplying in Switzerland. And one thing that causes a lot of problems in our discussion, 12 years ago, the Swiss energy strategy was a strategy that was looking at doing this together with the neighbors of Switzerland, with Germany, France, Italy. Today, relations have become a bit more sour, a bit more difficult. Major international agreements are not going to happen at the moment, or bilateral agreements. So Switzerland is more or less looking at doing this alone, as far as is possible. The second thing that is perhaps a bit special in Switzerland is that this is really a multi-level transition. So I come from the city of Basel. Basel aims at being at net zero in 2037. Switzerland aims at net zero in 2050, and 2050 is completely different in terms of strategy, because by 2050 we hopefully will have something like a hydrogen backbone. In Europe, we will have better knowledge how to do CCS, how to store carbon in the long run. I mean, if not, net zero will become very hard. Anyway, in 2037, none of this will exist. So how to achieve net zero in 2037 is much more difficult than doing this by 2050. And we have in Switzerland not just vastly different aims, we also have vastly different measures how to approach this. I mean, in Basel, we're discussing about a prohibition of oil-based heating systems. Try to do this in rural Switzerland. Politically, it's just infeasible. So it's very different measures, very different approaches, and this means we have to look at the energy transition as being something that is extremely complex. It's not just replacing one technology by another, it's much more complex. We have to think about the people involved, the actors involved, how do they take part in this transition. Now, one thing that Switzerland did, I think, in a very brilliant way, but I might be a bit biased here, is that at the onset of the energy transition in 2013, they said we need research. And to this end, they set up 8 big research centers in Switzerland, which had the aim of providing a nationally coordinated view on research dedicated to the energy transition. So we were tasked with coordinating research, bringing researchers together from all Swiss universities, and tasked with bringing the knowledge into the actual energy transition, that is, into industry and into politics. I had the pleasure of heading one of these research centers, the one that was not centered on a technology, but rather on everything else. So it was called CREST, looking at economy, environment, law, behavior, bit of a mixed bag in terms of researchers, but I think in the end it was a wonderful time. That's just a picture of all the people. Aya was, of course, part of this and involved. We had roughly 40 research groups. We founded 50 new research groups in Switzerland with the money we got. In total, we spent roughly a bit more than 100 million Swiss francs, which for non-technical energy research is quite a lot of money, and did, I think, a lot of work with this. So let's go into 2 examples, 2 things that we did. One thing is looking at electricity markets, and this was indeed a topic which was not on our initial research agenda. but it's something that industry brought to us. Industry contacted us and said, okay, we foresee problems with electricity market designs in Switzerland and in Europe. Could you please start thinking about what could we change here to make the energy transition happen? And there are two big problems. The one is quite well known. That's a graph from a paper by Leon Hirt, published in 2013, which basically shows that renewables are cannibalizing themselves. The more renewables we have in the system, the more often prices, or the more hours in the year we will have where prices approach zero, and as production of renewables is strongly correlated, we can't decide when to produce. That's for most renewables, that's weather given. It means that renewables will not make any money on electricity markets if there's a high share of renewables. So if you want to refund renewables by selling energy, you're in a bit of a problem. And that's what these pictures show. The economic value of an additional installation goes down rather rapidly, even for small shares of renewables. So that's one problem that we have. The other problem, and this is a session on resilience and solutions, and that's the one picture I have about resilience, is that the current electricity system is not resilient. And this is data that I took from the Swiss price regulator. It shows the effect in the end of the Ukrainian war on what's happening on the household level in Switzerland. So you see here the frequency of price increases in Rappen per kilowatt hour over all 600 utilities that we have in Switzerland from 2020 to 2021, and you see it's centered about 1 Rappen per kilowatt hour. That's what we had for the past 30 years. That's a normal change. This is 2021 to 2022, and this is what happened 2022 to 2023. And it's completely different. We've never ever seen something like this. And you have to keep in mind there was not even a major blackout or anything in Europe. It was just expectations. And a system that reacts so strongly to this is very clearly not a system that is very resilient. And I'll come back to the reasons in a moment. We see a huge change, and we see this again this year. So it's not a one-off effect. So what are the problems? And this is a paper that I've done with two colleagues at the University of Basel. We built, I'm a theorist, so we built a nice mathematical model describing what are the effects of the current market design. And there are a few problems. The first problem is that customers have a fixed price for electricity. So a pre-agreed price, usually 1 year ahead. We set a price, and that's a price level we will pay for every kilowatt hour of electricity. I think most of you will have a similar contract here in Germany. Perhaps there's a day and night price, but even this is pre-agreed. So the price signal, the price we pay, is completely detached from actual scarcity. And that's not what a market is supposed to be in economics. A market should reflect scarcities. It does not for end customers for electricity. The result is we do not have any, or we do not harness any demand-side flexibility, because customers have no incentive to use more electricity when it's abundant and less electricity when it's scarce. Furthermore, if we look at PV installations, this leads to a biased system, because if I always get the same amount, or if I always save the same price for every kilowatt hour that I get from my rooftop installation, I will just focus on an installation that provides as much energy as is possible, not as much usable or useful energy. So energy that occurs when there's scarcity. So in mornings, evenings, I will just build southern-facing solar systems because they typically provide the most energy, and that's optimal for a household. And then I already talked about this. The second problem is zero marginal cost leads to a situation where we get a lot of hours per year with zero prices on wholesale markets, which kind of reduces the incentives for larger investors to go into renewables. And security of supply, we want to have it, but we don't have demand-side flexibility, this creates tremendous rents, and this is what has driven this non-resilience, these electricity price increases before. It increases tremendous rents for flexible dispatchable technologies. And this is in Europe mostly natural gas-fired power plants, so it will be very hard to get rid of these plants for simple economic reasons. If we increase CO2 prices, the rents they have will just go up again. Now, what is the result of this? And this, as I said, is a purely theoretical analysis. We can document most things quite nicely with some data, but keep in mind it's theory. So what we will expect to see is too little investment in renewables, in variable renewables, too much investment in flexible dispatchables, and in the end, an inefficient portfolio of renewables which leads to huge peaks over noon in summer and not much winter electricity, not much electricity in the mornings and evenings. And to get to a working system, what we need is continuous interventions or continued interventions in electricity markets. And that's a basic message that we got here and that we got out to policymakers, telling them, okay, all those promotions, all those policies, that's not something that you just have to do because we don't have sufficient CO2 prices or because renewables are still not major enough, which is not true anyway. It is something you will have to do even in 20 and 30 years' time. And this is something, at least in my experience, policymakers totally did not have on their radar. They always thought it's something temporary and then we are back to a normal market situation, but this will not happen, not with the markets that we have today. So as we talk about solutions, what could we do about this? One option, of course, I'm an economist, so one option would be to use prices in their pure form, go to real-time pricing in electricity. Texas has done this, at least in parts of Texas. You've seen the results a few years ago. It was not so bright. The reason is real-time pricing only works if people react to prices. Otherwise, it doesn't make sense. And to react to prices, you have to know prices. So you have to take your phone and have to look at the current price and decide whether you want to cook now or want to turn on your lights or whatever, if you want to pay for this. I don't think most people will do this. So what would happen with real-time pricing is that we build a lot of automated devices that are pre-programmed to react to the price signal. But if we do this, we don't need real-time pricing. What we do in effect is just the utility sends a signal that switches some devices in a household on or off. And why do we need to call this a price? And why do we have to use a price that in the end will put a lot of risk on the electricity bills of end consumers? So there might be simpler solutions, and one way, that's what we propose here, is to say let's look at a completely different market design, where we do not trade energy anymore, but where we trade security of supply. So every end customer gets a different offers saying you can have a perfect level of security of supply as we have today in Europe, or you can have a reduced level of security of supply at reduced costs, of course. This provides demand-side flexibility, and customers will mostly pay for this security of supply. If electricity is abundant, we could even have zero costs per kilowatt hour for individual customers, incentivizing them to soak up electricity, which we would otherwise just cut off because we have too much of it. Now, we would need some regulation for this. So a regulator would have to make sure that a utility actually has the security of supply that it sells to its customers. So a utility would have to buy a production portfolio that matches, in terms of risks, what it supplies to its customers. And this is something which we know very well from the regulation of insurance companies. It's something that we do in other fields, so it's not something that's completely new. And the effect of this, if you think through these contracts, would be that utilities would have a huge incentive if they look at renewable installations not to buy renewables per kilowatt hour or megawatt hour, but to say, okay, you build a huge solar park, we just buy all the electricity that you produce, whenever it occurs, whatever it is, at a fixed price per year. And this moves the risk from the investor in PV to the utility and to some extent to the end customer, resulting in a much more rapid expansion of renewables. So that's a totally different idea how we could support renewables. We would not need promotion schemes anymore. Utilities would do this kind of security, would reduce the risks by themselves. And in the end, we can show, due to this, we would end up with a system where we have an almost efficient portfolio of renewables, because utilities would have an incentive to buy this kind of electricity, this kind of renewables that really matches a need in their portfolios. Not just electricity that's produced in summer over noon, but exactly the other things. Now, this is theory. How do we move this to practice? We're talking about solutions here. So what did we achieve with this? We spent, I think, 3 years by now discussing this with politicians, with industry in different formats. And I think we achieved quite a bit. So Switzerland just 10 days ago set up a new legal basis for its electricity markets. And there are some things that actually go directly into what we wanted to see. One thing is that they decided that demand-side flexibility actually belongs to end customers. So if utilities want to harness demand-side flexibility, they have to pay customers for supplying this flexibility, which is exactly what we want to see here. Second, there's an option for at least dynamic grid tariffs, not dynamic electricity prices yet, but this might come later. And most importantly, there's a so-called sandbox clause. That is, we are now allowed as scientists to experiment with real-world tariff designs, which is a major step forward, which allows us in the end to bring this kind of pricing scheme into practice and test it, whether it will work in the field or not. What's still lacking, as an economist, I have to complain about something, is that Switzerland is still sticking with regional monopolies. The idea that end customers might choose their electricity provider for some reason in Switzerland, which considers itself to be very liberal, is not palatable. Politicians just think people don't want it, this freedom. I don't know why. Second example, household energy demand. A totally different project out of the same research center. The big question here is Switzerland by now for, I think, 30 years tries to reduce energy usage of households with different schemes. In Basel, we have an electricity tax that's on top of normal electricity prices. Other cantons like Geneva have the same. There's a lot of information campaigns going on. There's a lot of norm-based campaigns. So a lot of things that have been tried, but none of it really worked. Energy demand of households has kind of leveled off, but it's not really going down in Switzerland by now. And again, we are coming to the topic of making policy or the energy transition perhaps a bit more artful, more crafty, looking at the handwork, how to do it. And the idea here was to say, okay, perhaps we should tailor policies to different groups of households, not just approach everyone with the same measure, but go into a bit more detail. And that's the idea of what we did here. So we had, out of a research center, a wonderful data set. I'm coming back to this in a moment. Analyzed this data set and then build an agent-based model for being able to simulate different policy measures. So first about the data. That's a data set, and that's where nationally coordinated research really becomes useful. It's a data set built up by colleagues, Professor Böhnke, Professor Farsi, Professor Brosch. Brosch, he's a psychologist, Farsi, he's an economist, Professor Böhnke is a philosopher, so it's a rather broad set of people involved here. It's data, representative data on 5,000 Swiss households, collected every year, now every second year, because we don't have the funding anymore to do it every year. It has very detailed information on appliances, heating systems, mobility demand that households have. It has very detailed information on attitudes, values, political orientation of households, on the information level that they have, the trust that they have in different information sources, and of course on social and demographic characteristics. What we did with this data set is first to run a huge number of regressions to figure out what are correlations. What are different clusters of households? How do they behave differently? And we build up 5 clusters. And we did this in a very particular way, not data-driven, but driven by the question, what is useful in policy? Because data-driven, we would have ended up with clusters where we say, okay, you should differentiate households according to their trust in government. But how do you target households with different trusts in government with policy measures? I mean, that's something you simply can't do. Distinguishing households according to where they live, how old they are, that's feasible. That's something you can actually do in practice. So that's a type of clustering that we used here. And you can see on the right-hand side, with this one example, what's the likelihood or what's the correlation between the car ownership, the likelihood that a household owns a car, and different variables like the susceptibility to injunctive norms or energy literacy. And you see that for the different clusters, these are these different lines, the relation looks very different. For some clusters, we don't see any correlation. For others, we see a quite strong correlation. And this is a first indication that tailored policy measures might actually work in practice. We did this again, just not as a picture here, but as some regression results for the question, what's the likelihood that a household owns a non-conventional heating system, so heat pump or wood pellet stove or something like this. And again, you see there's energy literacy, for example, has an effect on the full sample, but this effect only stems from 2 clusters, from 2 household segments. The other ones don't react. There's no correlation with energy literacy and the likelihood of owning a non-conventional heating system. So that's the kind of information that we use to build up a model. It's an agent-based model. All the decisions of the agents in the model were informed by the data, by the correlation that we found. We initialized the model with the data that we had, so 5,000 households in 5 waves. We can have roughly 10,000 agents in our model based simply on data that we have. And then we used a different data set to validate the model, to make sure that what we do here is actually close to what might happen in reality. And what we implemented, agent-based models are about the interactions of agents. So what we built in here is a mechanism where agents can actually talk to each other, conversations. So we can put in some information campaign or social norm-based campaign into the model, and it kind of spreads out in networks in these models. So these are kind of networks that we have. We have a neighborhood network, and if you remember the clusters that we have, a neighborhood network in a rural setting will remain a rural setting. So it connects a particular type of agents across ages, but not across locations. In contrast, a family network will connect across ages and will connect across location. And friend networks will remain in an age group, but will, of course, cross locations. So different networks. We simulated different scenarios for different parts of the model, and I will just show you some random results, just to illustrate what we get out of this kind of analysis. The first thing, of course, we are economists, we are looking at prices. So subsidizing energy-efficient appliances. You can see it has an effect, but the effect is pretty small. And the reason is simply that we are already with roughly 75% of energy-efficient devices, appliances in Switzerland. So 75% of all appliances a household owns are energy efficient already. It's difficult to get much higher. 100% is just not feasible. So a subsidy has some effect. On the other hand, information has absolutely no effect. So you don't see anything. For no cluster, for nothing. And if you look at actual policy measures, most of them are based on information, not on subsidies. So we are doing something wrong. What would work are norms, social norms, in this case descriptive norms, telling people, okay, all your peers, they own more efficient devices, a higher share of efficient devices than you do. This would have an effect, but not for everyone, but just for some particular groups. And on the right-hand side, it's a bit difficult to read this graph. What we compare here is the effect of a campaign that addresses all households versus the effect of a campaign that addresses only one particular segment and then spreads out via these networks. And you see that with targeting only a specific subgroup, you almost achieve the same effect. So comparison be the top line, and the line below, the red line, is what would happen if we don't do anything. So targeting might be more cost efficient. And finally, what would happen if we combine different instruments? This is the example of mobility, the number of cars a household typically owns. It's at the moment 1.08 in Switzerland in total. You can see you can reduce it a bit via prices with taxation. So it's a reduction from 1.08 to 1, which is not much, but almost 10%, which is still something. A literacy campaign, again, has some impact, but not a strong impact. But what has an impact is a descriptive norm campaign, again, using social norms and combining this with prices. And you see what we could achieve here is a reduction that's much stronger than what we would get with a single instrument. We could come to, if we have enough time, almost 20% of a reduction here, just by combining two instruments. So again, question, what does this imply in practice? First of all, on the federal level, I have to say we did not achieve anything. When the war in Ukraine started, energy saving was important, so what did the federal government do? They did an information campaign and spread it out to everyone. It's exactly the thing we tried to tell them for 5 years, it will not work. Anyway, they did it. However, on the different level, I said, in Switzerland, energy strategies are cantonal strategies to a large extent. We had quite an impact. So we kind of disabused policymakers of using information-based measures, showcased that it would be useful to target policy measures to particular groups. And for instance, in the city of Basel, we are now using for this Net Zero 2037 strategy a range of different measures that kind of target different groups. Most likely politicians in the end would have done these good measures anyway, these good policies anyway. I hope we were useful in saving a bit of time because 2730 is almost tomorrow. Now, let me conclude. In the title, I refer to economics. I think the most important conclusion that I have, it's not really economics. What we did here is a bit of economics, but mostly informed by a lot of different social sciences. And this interaction has been important. I mean, in our research center, we also had research that was pure economics. And as an economist, I fear to say that the impact, the measurable impact of this purely disciplinary research is almost zero. We don't have much to show for it. If we go for the more interdisciplinary route, we really see effects in practice. We see that the research was useful. Where economics has been tremendously useful is, on the one hand, aggregating results. So psychologists typically work on the individual level and have huge difficulties aggregating what they do on the individual level to aggregate outcomes. That's where economics perhaps has some useful tools. And where economics has been very useful is bringing this to policymakers. Because at least in Switzerland, they are kind of used to the economic language. They're kind of used to talk to economists, and they have much more difficulties to talk to historians or philosophers and to understand their language. So as a channel for providing insights as a language, it has proven to be quite useful. The second major conclusion I want to make is What Switzerland did here with this nationally coordinated research, it had some costs. Because national coordination means you don't have competition anymore, because everyone is in. There's no competition for grants. You just split it up in the research community as you like, and policymakers are out of the picture. They don't get to decide who gets what. So it has some costs, but in the end, it proved to be tremendously useful. We worked for 8 years with these centers. We were evaluated 10 times, which is quite often for 8 years. And all these 10 evaluations showed that it really changed the game. And the additional funds were just 4% of what Switzerland spends on energy research. So it's a very minor increase, which proved to be a huge game changer. And this is the main conclusion I took up out of these 10 years now, saying, okay, perhaps it's a good idea, if we want to really have solutions for a more sustainable world, to coordinate research on a national level, not to compete that much, but to collaborate, and then have a common way of bringing the research insights into practice. And if we could successfully do this for energy, why can't we do it for sustainability on a broader scale? That's what I wanted to say. Thanks a lot for listening to me, and I hope you have some questions.
That was the right answer. Yeah, many thanks. I think you are well prepared for taking some questions. Let me start with my personal comment on that. You in Switzerland are in a very lucky situation compared to Germany. What does it mean? You have base load renewables, hydropower, geothermal power, much more than we can have in Germany. And you have the pump storage lakes, so you have better possibilities for storage. So I think this is a favorable situation, just my personal comment. But now we are open for questions and remarks. Yes, please.
Thanks for the talk. I was a little bit puzzled why you tried to intervene with price regulations instead of letting the market do the job. So if renewable energy firms wouldn't earn any money anymore, wouldn't they rather invest in energy storage than something else?
The point is the point at which you stop earning money with renewables is, or much money with renewables, is in terms of the share of renewables much smaller than what we officially plan to have in 2030 or 2040. So, I mean, you don't have countries where renewables just happen, even though they are cost efficient, just happen on their own. Most countries have some support schemes, even if they don't call it this way, to bring renewables into the market. So it's not a question of whether to intervene, but how to intervene and how long to intervene. By itself, it simply doesn't happen. And regarding storage, of course, day-night storage, that's something that we see in practice, but seasonal storage, and even pumped hydro storage is not a good seasonal storage, is something that's at the moment still economically out of the question. Very few firms are building this.
One add-on question. Has Switzerland thought about selling this over excess of energy to other neighboring countries? Seems logic to me, because that's what's usually done in Europe.
I mean, that's how pump storage is used in Switzerland. It's not used for Swiss purposes. It's used to stabilize the European grid on a tiny scale, because on the European level, it's a lot for Switzerland, but not that much on the European level. That's how companies in Switzerland live. There's no Swiss electricity price. It's a price out of Leipzig, the EEX price, that's driving what the firms are actually doing.
That is what we call in Germany the Swiss or the Austrian business case. If the price for PV dropped down to minus prices below zero, then we sell it to Austria or to Switzerland, to the pump storage lakes, and the next day we buy it back with positive prices. This is excellent price model. There is another question here, please.
Yeah, hi, thank you for your talk. So when we talk about access to energy or looking at demand side flexibility, it also means that people who aren't traditionally able to access energy or able to pay for the access to energy are still left out of that level of availability for that energy. So it doesn't matter whether, I mean, if you are focusing on demand side flexibility, then it doesn't matter whether you're talking about renewable energy. The people who can't access energy as poor people are still unable to access it because it depends on how much you are able to afford or able to pay for it. So then how do you see that in terms of like a just transition into renewable energy, and how do you look at that kind of economics? And I also have another question. It's a little different. So about the energy market, in the sense that even when there was an energy crisis because of the war, later the market kind of stabilized because a middleman like India bought energy like oil and gas from Russia and then sold it to Europe. So it's basically, we're still back to the same thing again. And there was no incentive for, I mean, why rather was there no incentive for renewable energy players to then do more and make money out of that level of crisis? And then, yeah, why didn't that happen? Yeah.
Okay, perhaps the second question first, because that's easier to answer. I think there is a major incentive, and there has been a major incentive, but we are just running into bottlenecks. So the actual capacity to build renewables is pretty much exhausted in Europe. So if you build today, if you want to have a PV installation in Germany and Switzerland, I can tell you, you're waiting for 2 years right now. So if you say, I want to have rooftop PV, typically you will have to wait 2 years until you get someone to build it for you. So I think that's a reason why we don't see much of a reaction, because we're already almost at the capacity limits, and this capacity needs to be expanded, but that requires a lot of education, that requires a lot of training. Regarding your first question, yes, there is a justice problem. I agree, and this problem will not go away with any market design that I propose here. However, I think we have, at the moment, a justice problem or a direction that's going into the wrong direction. So what we see in Switzerland, I'm not so sure about Germany, is that the households that own a home, that's usually households that have a bit more money, they can build PV installations. And they are supported because they don't have to pay that much anymore for all the grid surcharges, for grid tariffs. So it's kind of using money from all the other actors in the market, the poorer households, and channeling this money to the richer households. And at least that's something we would get rid of. I'm not saying it solves all the problems, but perhaps it at least changes the direction into something that's a bit better.
Yeah, thank you. Yes, please.
Thank you for your presentation. I just want to ask about the data that you use. It's about the household, decreasing the household demand for energy. I know that there are some scenarios which are assuming that we need to decrease the energy consumption. So this is the least efficient part of the energy cycle, they say. And here, most of the scientists say the same thing. We need to reduce the material demand and energy demand to reach the targets of 1.5 and 2. So here, I just want to learn how Swiss population is divided into social groups in the data that you use. Because I just also want to make such a social group targeting. So I just want to ask this.
So we tried out many different segmentations. In the end, we stuck with what I've presented here, which is just, let's say, life stages. Young people, typically all still in training or building up a family, middle-aged people, working, having kids potentially, retired people, and then rural versus urban, which is very important in Switzerland. I'm not sure whether this would be important in Germany. But if you look at attitudes, if you look at values, rural-urban is a nice proxy. And you see this in voting behavior, for instance, in Switzerland. So that's why we use this distinction. That's how we did it. Data-driven, we would have had much better segmentations, but they would not have been useful in practice because you can't target many things. You can't target values or attitudes with policy measures. So that's how we did. I hope I got your questions right.
Yep. We have a second, another question here.
Yeah, thank you very much for this very interesting analysis. You showed very nicely that the social norm is so important. So I was wondering if you have some instruments to positively influence the social norm.
So what we looked at here are two types of norms. We looked at descriptive norms. They were useful in some contexts. Descriptive norms meaning you just make transparent what people actually do, and emphasizing perhaps a bit more the good things than the not so good things. So you just make transparent that a lot of people already own an EV or have a PV installation. That's a descriptive norm approach, and that's quite doable, and that's something we try to do in Switzerland quite often. The thing that's more difficult, but also more effectful, at least in some groups, is injunctive norms saying what you ought to do. And this is politically a bit more difficult, telling people that it would be good if you would do this or that. During the Ukrainian war, it was quite simple, telling people that saving energy is actually good for everyone. So this would have been a very simple campaign. I don't know why they stuck with campaigns that were more going into the direction of, okay, you can save a lot of money by saving energy. But yeah.
Probably because the price of electricity is still too low. It's not the real motivation to save electricity. Okay, any more questions? There are not. I think you have given us an excellent insight in the view of, let me say, economy interaction with sociology, with politics, and I think we have to thank you again pretty much. We will now go ahead with the next presentation, and this is a special pleasure for me to introduce Nicolas Moussiopoulos. He is a professor at the Aristotle University in Thessaloniki. He received his PhD, a doctor engineer, and later his habilitation at the University of Karlsruhe at the same time when I studied here. So we know each other since then. He has been educated in mechanical engineering. Later, he became the professor in Thessaloniki. He has served as a dean in the Faculty of Engineering. He has served as a vice president on the International Hellenic University. And he will introduce briefly now the atmospheric forcing modeling on critical road infrastructures within the frame of the EU ANOPTIS project. Nikos, please, it's up to you.
Thank you very much, dear Karl Friedrich, for this very kind introduction. Of course, the title makes clear that engineers were already in the 80s very concerned on the possible problems that such studies are necessary, and therefore in this session on solutions and resilience, I'm very glad to present some results of our recent ANOPTIS project. Allow me to acknowledge the important contributions of my co-workers and colleagues, Dr. Sparmpas and Tsegas. George Tsegas is present here in the audience. And I would like to start with the clear message that there are road infrastructures which are increasingly vulnerable. And why? This simply because the demand could rise, the uses may change. Aging, as for everything in this planet, causes problems, but of course also climate change, and especially the extreme weather conditions. And what you see here are pictures from the recent catastrophic thunderstorms in Volos, which is in the center part of Greece. Maybe some of you know the Pelion mountain. And you see that these road infrastructures, this used to be a bridge, and this is not a matchbox but a car. And this used to be a street, were totally ruined because of the incredible masses of water flowing down the mountain. So to return to the better picture, which is not such catastrophic, there are other hazards as well, and there are, of course, effects that may amplify the vulnerability, poor maintenance, and other things, which I don't want to go into detail. Therefore, in this project, a number of companies, together with a number of research institutions, wanted to check whether by leveraging existing tools and services in combination with the use, of course, also of novel technologies, one can do something. The aim is actually to obtain a platform that could be applied to such road infrastructures in order to address all these issues, to have possibly ways to prevent, and if nothing else can happen, at least to inform as speedy as possible on the potential risks. All those who could be affected, like the driver of this matchbox I showed before. So I cannot go into too many details on the project as a whole. As you can imagine, there have been plenty of sensors which should be available in order to understand the situation with in situ measurements and smart sensors, and of course very nicely linked via internet and whatsoever. And the manager of the infrastructure should have something like an operations center where all this information flows in, together with a number of additional things. And what we were in charge with, together with colleagues from the Finnish Meteorological Institute, modeling tools which could help complete the picture, if you want. This, of course, means that we need here a lot of information in order to integrate the sensor data. And again, as you see, what is necessary is to have nowcasting and forecasting. Nowcasting means what happens next hour. And here we, of course, have also the chance to apply what is called data assimilation. For the non-experts in this topic, it means that you can use existing measured information in order to improve your prediction for the next hour. And I will show you how important this is a little later. But of course, also forecasting for the next 24 hours in case that this information is also needed. What actually is very important is to be able to issue, if necessary, warnings and alerts. In Greece, actually, we had, luckily, during this catastrophic thunderstorm periods 1 month ago, such alerts via the smartphones, and this prevented, I think, quite a number of casualties because people were very early enough, I would say, informed not to go out if they didn't have to do so. And this is something that will, of course, increasingly be introduced in other countries as well. No time to go into details from this quite busy slide, which shows that as everything in this atmosphere is a multi-scale problem, you need something like a boundary condition for such a road infrastructure, which comes from the regional scale. What we did is to use the ICON EU model, more precisely a data repository for typical situations where we could get our boundary conditions. And you see here what we did together with our Finnish colleagues. What we did was the mesoscale. The Finnish colleagues were then more in the local scale using the large eddy simulation technique, model PALM-LES, which we also use in our laboratory, but we decided to share forces here. And in the lowest panel, you see, of course, also the results. in addition to what we could provide, the Finnish colleagues were able, going into the local scale, to provide information on gusts and the more detailed dynamics of turbulence in very low scales. For historic reasons, what we applied in this project was the mesoscale model MEMO. As you see here, there are two columns of models which were developed in the last 4 decades, initially only in Karlsruhe, then gradually some of the development moved to Greece together with me, and the last PhD in Karlsruhe was 2013 on this development. So the left column has to do with the atmospheric flow, the right flow has to do with transport and transformation of pollutants. Initially, we developed them separately, but 15 years ago, as most of the colleagues all over the world, we noticed that we needed online coupling, because as some of you know, smoke layers, especially aerosols, may lead to some changes in the radiation exchange in the atmosphere, and this has, of course, an impact on the dynamics of the boundary layer, which is, as you see in the middle, materialized with this routine, and this online coupling is, of course, now, I would say, standard. Something more on history. The development took place in the frame of a number of large international activities. To start with the Eurotrack project, which was a Eureka sub-project, let's say part of Eureka at that time, starting in the 80s, by the way, of the last century. Then we continued with the Network of Excellence Accent, where most of this work was then completed, I would say. And the first real application was in the Megapoly project, which was coordinated by the Max Planck Institute in Mainz. It was the first time, by the way, where experts on climate modeling, weather forecasting, and dispersion modeling set together. Until then, it was a separate thing, and nobody knew exactly what the others were doing. And since then, we have this holistic view, and this is very positive. To MEMO only the fact that it is a model which, as I said, is a mesoscale model. We are very much, as, let's say, engineers, we wish to see the dynamics of the boundary layer well developed, and we were able to prove that this works in a number of projects over the decades. I have no time to go into many details, but what we're doing last years is to try to find application areas, not only for road infrastructures, this is ANOPTIS, but as you say, Hyperion project, which is just about to end, has to do with the heritage, culture again. What all these things mean, also climate change means for the fate of such historic monuments all over the world, actually. Not time enough to go into too many details on what our Finnish colleagues are doing, but for completeness, I included this transparency, and if the slides will be made available, you can see more. In fact, the detailed results, which have already been addressed, are shown also on this slide. Let me come now to one typical example of what we are doing with all these things. This is an application for a site in a very mountainous area. In fact, this is this area here on an elevation of about 1,000 meters. People here in Greece think of coasts, beaches, and so on, but Greece is more mountainous than Germany. We have in this area where this motorway, this is the second most important motorway in the country, and by far most expensive one, goes from the west coast, this is the harbor of Igoumenitsa, to the Turkish frontier. This is the Egnatia motorway, the modern Via Egnatia, by the way, for those who know the history. And in fact, the area which we modeled is the area around the city of Metsovo, as I said, more than 1,000 meters. And there are infrastructures which are quite vulnerable there, as you will see in a moment. We modeled this area with a resolution of 500 meters. And in fact, there is a bridge there at this elevation where icing and fog incidents appear to be quite frequent, and therefore it's very important to know in advance, of course, when this could happen in order to inform the drivers and to take precautions of other type. And what you see on the left panel is the temperature, and you can imagine from the scale you see the larger blue areas below 0 degrees centigrade. Here you see also the typical, let's say, diagonal variations for two places in this area of this bridge, below 0, with quite high also, of course, humidity. And the Finnish colleagues provide more information. Here is a panel, the left panel, which you see here in more details. And you see the gas distribution at 2 meters height for this area. And they also can provide turbulence turbulent quantities, or the winds in cross sections in very nice details, which complement what we provide with our mesoscale model. And as I said, in our case, we have the feature of the applying data assimilation using the results of the current hour measurements from the sensors. And this greatly improves the accuracy of the next hour nowcasts. The table is of course busy, but I would like to focus on the last 2 lines, which is the index of agreement. Upper line without the assimilation, lower line with the assimilation. And if you simply compare the numbers, one is optimum, then you see that the index improves considerably if you use this present hour measurement. Last 2 minutes, dear Kafi, to say that in addition to what we provided for this consortium, we dealt also with the question on what could be the climate change effects. As you of course know, IPCC usually focuses on global scale models and what is necessary, and what we also did already before PANOPTIS is to work on downscaling, because some of the consequences occur at lower scales. And incidentally, what we did for years is to work on Eurocordex. As you know, Cordex, of course, is within the World Climate Research Program, well manifested for such global scale analysis. And within Eurocordex, we wanted to see the more regional scale impacts. And from there, you can even go beyond and go even to local scale. And only one table here with results, and even mainly these 3 columns, where I would like to stress that climate change can have even positive results, because the indices regarding frost and icing get better, less days of frost and icing, of course, because of the increasing temperature. You see on the rightmost column that the diurnal temperature range increases from now, let's say, until the end of the century by about 0.15 Kelvin, not degrees Celsius, Kelvin. From thermodynamics, we were also always asking for calling differences, for using Kelvin for the differences in temperature, by the way. So let me summarize. Meteorological and climatic effects are very important for all infrastructures. We have the tools which we can apply both for the management of these infrastructures, but also for dealing with the issue what will happen in the years to come if we will not, which appears likely, will not be able to prevent the change of our climate. And with this, I would like to thank you very much. What happened now? Okay, so something happened and I don't have now my email here. I would like to thank you for your attention. Of course, I'm prepared to answer any questions you might have. Thank you. It's really gefährlich.
This is
quite risky.
This is really dangerous.
And our tools do not help to avoid.
Yeah, many thanks for your presentation. It's open for discussion or questions. I have one question is, how do you transfer this scientific knowledge to practical application? I mean, how open is the society for Autobahn and highway to receive this information and use it?
Yes, within the project we had, I have the...
Okay.
Within the project we had 2 applications where the local managers were involved in Spain and in Greece, but the whole project led to more or less recommendations on how such a management system would look like. We are not the only modelers, and the sensor providers are all over Europe available. And what we suggest is to have that they need such a well-equipped system, together maybe with such incident management methods where they know for the identified risks what to do in case that people should be informed either to avoid using the infrastructure, or those who are already on the motorway to be prepared will they face when they will reach this bridge, for instance, or any other part of the infrastructure that might be on risk.
Okay, yes, please.
Very interesting talk, and I had a question related to the continuation maybe of this approach, because I saw in one slide that you had a lot of sensing instrumentation also related to critical infrastructure. And so the insights that you gain from this particular project, can they be transported to other projects? Is a continuation foreseen?
Well, within the project we had, of course, a number of, as I said, companies who are potential suppliers for the infrastructure to any authority involved in maintaining and managing the infrastructures. So the project fulfilled the task of disseminating this information. To what extent, of course, this will be used is something that I cannot foresee, but we believe that this is necessary because the costs which you have if an accident occurs are much higher than the costs which you will have in order to get the infrastructure necessary for getting the information and the information to work for the benefits of the users of the infrastructure.
And so this Panoptis, by the way, the name is very nice. So it was EU funded, right?
Yes.
Okay.
Yes.
So there could be a continuation, actually.
There could, of course, be, but as I said, as you know, in all these projects, there's also a dissemination task. We made a number of presentations, and this one is one of these, by the way, where we make clear that all partners I showed in one of the slides are available if services have to be provided or any type of guidance. So this is available, and we can only recommend that this is done.
Thank you.
Thank you. Any other question, comment? So I would like to thank again to Nikos, and by the way, I would like to express his motivation to build a strong link between the University of Thessaloniki and the KIT. And we did it together also with Johannes Orphal during the last years. And there is a strong link, meanwhile, between Thessaloniki and Karlsruhe.
And as you can imagine, it's a pleasure for me.
Thank you so much, and let's thank again.
Thank you.
We continue with the next presentation, which is a colleague of mine here at KIT. It's Dr. Richard Fuchs, and he is with the KIT Campus Alpin. Campus Alpin is the name for our institute in Garmisch-Partenkirchen, a place where I always had a good reason to go for a business trip there, because this is a marvelous place. You received, if I'm informed, your PhD in Wageningen, and you work in the Department of Land Use Change and Climate. And your presentation today, quite interesting, is called Agriculture 4.0. Decoupling food production from the land. Thank you. It's for you. Open here.
Thank you for the introduction. And so we will make now quite a shift to global food production topic-wise. And I feel very delighted to be put in the solutions section. But I would like to manage also a little bit the expectations from this talk here. So I hope I can present some potentials for solutions, but I think also what I would like to show you is an explorative study where we just to find out potentials for upscaling in the food production sector. So take all the results a little bit with salt of grain, but you will see also quite some bold statements there. So, but happy to discuss about this. So before I dive into this topic, what I mean with Agriculture 4.0, I would like to remind you of the challenges we currently face. So as you know, we are already producing food at quite intensive levels with all negative consequences. We experience the results of climate change, we deforest natural habitats, and we use quite a lot of inputs like pesticides and fertilizer to produce that land. But the challenges are quite severe for the coming future. So we will have until 2050 another 2 billion people on this planet. We will reach 10 billion people on this planet. And this means we need at least another 60% in calories being produced by that time. And this is a very optimistic number because it doesn't account for shocks. So shocks like wars, trade wars, pandemics, or the severe climate effects, and you're pretty sure you have seen many of those the last couple of years, and this will just increase. So even with that in mind, that we probably have to produce even more than these 60%, we already know that the current trajectory of yield increases is not enough to avoid net land expansion. So we know that with the current trend in yield increases, we have to produce at least on 2 times the size of India, or expand the production on 2 times the size of India. So this leaves some challenges for us how we can increase the yields. And there are different approaches how to do this, how to react to these challenges of the future. For example, the European Union does this with their European Green Deal, and they have a concept which is called land sharing. So they try to de-intensify landscapes, still produce on relatively high levels, but they try to increase the ecosystem values, but still produce enough food. But this has some downsides. Not necessarily for Europe, but for the entire globe, because often those approaches of land sharing approaches lead to outsourcing of production elsewhere in the world. And that's what we see. We move production to the global south, where we deforest nature's last reserves. And there was a lot of criticism, also one paper by us. And so our idea also evolved, is it not better to have a land sparing approach, where we actually try to increase the production at a certain region, and therefore avoid the expansion into other regions elsewhere in the world. And I was thinking of if emerging technologies or even biotechnologies can actually do this job. And I was thinking of 3 different platforms here. Indoor farming environments like greenhouses, but also vertical farms, gene editing, and alternative protein sources. And the reason why I'm thinking of these is because they are relatively mature operational, and they are ready to be applied on the market. And they offer exactly these twin benefits, what we are looking for this land sparing approach, that they have a potential to save land area and the chemical inputs we need. And best of all, they could also be potentially combined. So what do I mean with agriculture 4.0? So this is not a new invention, but I copied this approach more or less from the industry 4.0. So if you think about industry 4.0, it's often referred to as the 4th industrial revolution. Think about that, what you would like, if you think that's happening or not. But I would like to focus on the features. And the features are that we see sub-technologies in those industries that really make a difference, like artificial intelligence, gene editing, advanced robotics, machine-to-machine communication, or the Internet of Things. All buzzwords, I know, but what we see is that we have an improved communication amongst machines, that they can diagnose, analyze by themselves without the human intervention, which saves also a lot of labor costs. And I think most importantly, it's characterized by joining technologies to build a cumulative effect on efficiency. So I would like to dive deeper into this example. So if you think about vertical farming, you could compare this against conventional. So normally you have conventional agriculture produces on one layer, and you have the daily cycle of 12 hours sunlight where you can produce. If you move to an indoor environment, you could basically enlight these plants, in case of wheat, up to 22 hours per day, and throughout the entire year. So, and even on one level, you could harvest 5 to 6 times per year. And if you scale this, so if you stack this, then you can achieve a multitude of this, like incredible yields of 60 times of harvest compared to a conventional field. But what all these studies neglect is that this costs a lot of energy, and we don't know how much energy that's actually using. And this energy also, again, uses a lot of land. So this started a little bit from there. So there are studies that measure also the energy consumption in there. So in these experiments where they produced wheat indoors on one level but harvest 5 to 6 times, they used around 5,000 kilowatt hours per square meter per year. And they were able to achieve on one layer 60 tons per hectare, which is quite a lot compared to the global average. But the crucial question is where to get the energy from. So if you want to make this sustainable, we have to use renewables. And if you think of PV installations, my colleague Ankita Saxena, she studies PV deployment and the potential for energy generation by these systems. And what you see is if we would, let's say, use wheat fields for solar energy in these yellow-orange regions, you would only achieve a fraction of what we actually would need to achieve those yields, so it's not enough. And on top, these are just the potentials irrespectively of the solar panels you would use. If you take silicon PVs that have an efficiency rate of 25% roughly, then you can only utilize a quarter of that. But still, if you take this, you are more or less about in the range of the global average of wheat production. And we haven't accounted yet for the efficiency increases in the near future. So I was just looking, okay, what are the historic trends of each of these individual technologies and efficiency gains? So basically their learning curves in their production cycles. And if you take the wheat, the gene editing, and the PV cells and the LEDs together, they have quite remarkable efficiency gains. But again, when coming back to this industry or agriculture 4.0, you have joining technologies that kind of feed into each other. And if you're able in a system to basically compound these efficiency gains, then you could enter potentially into this exponential increase in yields. And so potentially leading to an increase in yields compared to conventional scenarios. And if you think, okay, then PV has to scale a lot. Is this even possible? I would just like to remind you that in this yellow graph here, solar energy or the PV energy is currently the energy dropping the fastest in price compared to all other energy sources. And at the same time, it's the one that's deployed the fastest. So it could be possible. And if you look at the historic deployment rates of solar, of wind, of batteries, you see quite a linear trend on a logarithmic scale. And it's interesting that they will level off at some point, where currently we assume the market demand is met for net zero scenarios, for example. And at the same time, you see that the prices drop significantly. And that in red, the integrated assessment models got the price forecast always wrong. So it dropped faster in price than we actually initially thought. So, and this is, of course, also related to each other in this economic law, rights law, where every cumulative doubling leads actually to a constant price drop in the future. And this is something we can use for the forecast. So if you know how much we deploy, we could also forecast the prices for this. And I was just trying to calculate this very bold for the entire globe, what the net benefit would be. So with all these efficiencies. So if you take the current state, in orange is the conventional production, which uses some 50 million hectares of land. And we would apply the efficiencies of today for all these technologies in agriculture 4.0 environment, we would not be better off, but we would be about equally this range. But given a little bit of time and accounting for the efficiency increases, and of course we would need still twice the size of India for conventional production, we would be by the time better off. And even if you take a conventional approach and say no new PV technologies are taking over, we still produce silicon PVs, then, and you also assume not everything will be produced indoors, you can see that there's quite a significant impact on the land demand. So even 25% of indoor farming could lead to a 20% reduction in the land area required for the production. And these are quite large numbers that have quite some impact on the planet. And what you see is, I just put here in brackets what this means in terms of size compared to Germany. But the downside is, or the challenge is, this requires enormous amounts of energy. And the question is where to take this from. So how to read this? So this means if you would produce 50% indoors, this would mean you would need 1 million terawatt hours per year, which is about 6-fold increase in energy supply. Is it possible? So again, my colleague Ankita Saxena, she just tried to assess how much energy we could produce if we would. So there are always different technologies here in these columns, and 4 of them belong together. And what she just did, she just checked what would happen if we would put solar panels on 0.5% of the land area. The next 4 are on 2% of the land area, 3.5% and 5%. And then she accounted for different technologies like silicon, perovskite and multi-junction cells, how much energy we are able to produce, and the different subbars here refer to different climate scenarios. So what she found, for example, if you take silicon and just assume we continue with the current technology we have and just utilize 2% of the land for PV production, and this is the urban area of in 2050. So just imagine if we would, everyone would put PVs on their rooftop, that we could be there. And if you then go to the right, you see that we end up with roughly 6-fold increase in energy demand by 2050. So we could be there. So actually, the point is we have a net positive effect for us. So we use less land for the PV than we would actually use for the agriculture and potentially save more of that. So if you think a 6-fold increase, still unusual, I would just like to remind you of the 1950s, where actually oil and gas became commercially viable and actually led to a change in energy production. So also here we saw quite a change in trend from these old energy forms, and I'm pretty much convinced that renewables will also lead to a trend change in the near future and when they be scaled even more. But there's, so just to conclude and give a little bit of some outlook. So I think there is some potential to produce larger amounts of food indoors in the near future, which also have a net positive effect on the land use, and then also require less inputs because you can recycle fertilizers, you can basically ignore pesticides, you can recycle the water use and the leakage effects into the environment, and you could decrease food transport because you produce it closer to urban centers. And of course, because of the decoupling from the environment, you're also less prone to these shocks like climate events like droughts and heats and so on. So in our group, we are now slowly moving from this explorative study to more predictive scenarios. So what we would like to do is to really develop scenarios to indicate when, where, and why these technologies would take off, and we do this with a spatial explicit modeling approach on the globe. And there are still open questions, so what about the raw materials? Are these available to actually supply this change? What's about the social acceptance and all these ethical concerns? So it could well be that if these technologies take off, they just disrupt rural livelihoods, which can't defend themselves against those technologies. And then also the cost reduction, we would like to prove and calculate how much we could reduce these costs, and how's policy reacting? Is it over-regulating? Is it deregulating? Maybe it's different in different regions. And most of all, what could we do with the saved land area? Could we use that for afforestation to store carbon, and what would this have finally on the climate? And maybe if you are thinking that there's some potential to answer those questions and help us, I was just thinking of if the KIT Future Fields funding might be a nice opportunity for collaboration. And with that, thank you.
Yeah, many thanks. I'm really impressed about this perspective. Really new ideas here in the future. I'm wondering a bit about this energy analysis which you made and compared it for the use in agriculture. I agree with you that we can expect a further drop down of the price of PV produced electricity. We recently had in Berlin this first time given Helmholtz High Impact Award for the tandem solar cells, which promise much better efficiency. So I think that is okay, but not only photovoltaics is a solution. We have also the other renewables, or let me say CO2-free production method. From a French point of view, we would have also the nuclear inside for electricity production as a fossil-free technology. So, but I stop my saying and I ask for questions. Johannes.
I'm sorry, but I have a really question, and I think it belongs to this conference, because we also started with this arts talk this morning. So beware what comes now, but it's just about the social aspects, yeah? So for centuries, maybe, you know, thousands of years, the profession of peasants, yeah, of agriculture people, was kind of romanticized. So yeah, they provide us with food, and so there are a lot of songs and fairy tales and whatever. Of course, it has never been that romantic, I would say. But have you talked, I mean, to different people who work in that sector, how they perceive this really disruptive transition that must come? I think the question how, whether it's 3-5 semiconductors or perovskite or whatever, but it must come, as you mentioned in the beginning. We have to feed all the people, but it will change totally this profession. And how is this considered by those who really work there?
I think it's seen differently because especially farmers, they have different viewpoints. Some see themselves more in this romantic space, like back to the roots rather than back to the future. You have others that are willing to invest and try something new. So I also participated in some farmer associations with farmers really maintaining large farms, and they actually would like to proceed in Europe, but the thing is they are stopped. So by regulations. So for example, PV deployment is not well subsidized for these farmers, so they can't put it on the fields, they can put it on their rooftops, but they cannot switch a field meant for food production now used for PV. Or if you take gene editing, it's a huge hot debate in Europe, and a lot of people criticize this and they don't want to use this, so they can't apply it. And I don't want to dive into vertical farms because they are completely out of any subsidy scheme of the European Union. And in other worlds, we see slightly different paths. So there are regions that have a limited land availability, like Japan, Singapore, China also, and they move really to deregulation to actually foster those. And my fear is a little bit we lose this kind of race as Europe. So I think we could do more.
Thank you. Thank you.
Yeah, thank you. Nicolas?
A very nice talk, and I have a question on your opinion on biomass potential. We saw in Switzerland they had noticed that this was on one of the slides. Denmark will be free of any need of natural gas 2035, as they are fully in a position to cover their needs with biomass, biogas. What is your opinion? If you increase the outputs with the multi-story, let's say, option, you would then have more biomass as more or less agricultural residues, which then could be used to produce energy and then cover part of your additional energy needs. Can you comment on this?
So in general, those systems just lead this purest form of energy, which is the electricity, right? So, but in theory, you could supply any kind of energy form. This could come from wind. We haven't dived even into that, and it's also we're just considering currently the land. You could also produce that offshore, right? And in terms of bioenergy, I'm a little bit more concerned because I think then you get a trade-off in land competition of forests. So there's probably some excess of biomass, or maybe even from the field, let's say harvest remainings, which you could utilize to produce this energy. But I'm doubting a little bit that this will be enough. It could be, let's say, an ingredient, but it probably won't be solving all these issues.
Thank you.
Okay. Yes, Frank, next.
Yes, just two questions. The first one, I mean, to me, this looks a bit like the story. I found it a very visionary talk, so thanks a lot. But it looks a bit like the story that we have in aquaculture. I mean, they try to do this not that romantic thing, moving away from the fisherwomen to industrial production. So have you thought about what you got there in insights in this field and practice, how this could translate to what you have here? And the second point, I mean, there will be a lot of additional energy demands. People do not only want to eat, a lot of people will need more energy, and carbon capture and sequestration will use tremendous amounts of energy in the future, where we might already need all this six-fold increase just to manage this, despite all the things you would like to see.
I have two radical answers. So the first one is, if you look at aquacultures, or in general fish consumption globally, it's a linear trend upwards. But you see somewhere in the 80s that this wild catch of fish flattens out. And everything from the demand side is basically caught up by aquaculture. So I think they have their use, and they are already probably in the scaling operations for supplying this for the demand. So I think there we could see how the supply could be met. In terms of carbon capture storage, I'm always puzzled. So I also saw here at KIT projects that would like to take the carbon out of the atmosphere and store it somewhere, and this is still with renewables, which would also require these solar panel fields, if you will. But why not, again, then you have this competition against food production. Why not utilizing this carbon or the radiation from the solar panels and then store it in food, what we actually can use? I think this is a much more direct use where you don't have the competition against land.
Yes, please. But by the way, I think this is an excellent question for discussion during the lunch break. But yeah.
Okay, it's maybe more of a comment. In the moment, about 1,000 terawatt hours are used for non-energetic purposes, making plastics and so on. And I mean, the amount of wood which is used, also biomass, is the only one which basically could be used from the bio side to replace this. Simply, this is about 600 to 800 terawatt hours. So this means bioproducts, in principle, in the future, are the only option to replace plastic products. So therefore, the use of burning bioproducts is, in my opinion, the wrong thing, producing hydrogen out of it or anything else. So the focus should be to use biomass, also agriculture products, to put this into non-energetic materials. I don't know if you agree, but thanks.
Yep, thank you. Well, I agree. I think this is the usual competition then you have with the land resources, yeah.
Okay, and with that, I would like to thank you again for your presentation. And we come now to the last speaker of this session, and after that, the chairman of the conference will do the closing. I would like to invite Dr. Denise-Heike Böhnke, my colleague from KIT. She is a scientific officer at KIT Urban Research, and she has been educated in academic geoecology in Karlsruhe, and you received also your PhD here in Karlsruhe. So, and you will introduce a platform for urban research at KIT as a part of the solution. Please.
Thank you. Thank you very much. Yeah, it works perfect. Good. So, hello to everyone. I know I have a very diverse audience, so I try to give you some facts about cities first. Why we should research in this area, and of course what we do, and I hope I will do that in a very interesting way for you. Thank you for your nice introduction. So my first question is, why cities? And of course, when I speak of cities, it's more like a narrative or a paradigm. Behind that is, of course, a complex social system with many actors and many stakeholders inside. And of course, we are now in a city, we live there. It's our habitat where most of the people live, but you will see that in a moment. So maybe you didn't know, maybe you know that our millennium now is called the age of cities or urbanization. Why is that? in our former times, we were not able to live in cities like we do today. So globalization, industrialization, and also agriculture. Haber-Bosch was working here at KIT, made it possible that we can live in a city in so many, with so many people, and that we can feed them. And that all over the world. So this way of living in cities is quite a new thing if you think of human mankind's long history. And since 2007, we have the same amount of people living in cities than in rural areas, which was normal in all the thousands of years before. So, and is it just a shift? Is it just a redistribution that people come from the land side to the cities? It's not like that. We have several effects due to the industrialization and all that is coming with it, which is the world population was growing so tremendous in the last 100 years, going from 1.6 billion to 7.9 now, or we are getting the 8 soon, and what you already said, 10 million soon. So we have a lot of people, a lot of more people, and a lot of more people living and going into the cities. So in the end, it means we have a lot of more people living in cities. Just the amount of people that live in Karlsruhe or other cities is just growing tremendous in the next years, and did so in the last 30 years. And with that, we just spoke about land. So this urban land consumption, so the growing, the urbanization trend of consuming land is even higher. It's 50% higher than the population growth. What does it mean? The World Bank says that 1.2 million hectares of area will be consumed by cities until 2030. This is in 7 years. And I asked ChatGPT, which country has this size? And this is what ChatGPT said. It's Saudi Arabia. It's quite a huge country. It's a really big number, only cities. Just a city. And for me, I like pictures very much to, let's say, grasp the meaning of things much better. So if we speak of what cities account for, so not going to a picture now, but in the next slide, we have 3% or 1 to 3% of land area that they use at the moment. 57% of the world population living in cities, and an even higher percentage, 70% of energy consumption and greenhouse gas emissions used by cities, this entity, this complex system. They produce 80% of all waste, and on the other side, 80% of the global GDP is generated there. So what I see is we have a lot of responsibility coming from the cities, looking at sustainability and climate change on the one hand, and on the other hand, a great potential looking at the financial aspect. So speaking of pictures, I like this picture very much because it shows that cities don't only use the land that they actually use, like we are living in, but they need a lot of more land to supply the people. It's 200 times coming from this report. There are many other reports, so don't fix me on the numbers, but just the idea. And the waste is even 4 times more in this case. So this is based on the 29 biggest cities in the Baltic region in the last century. So yeah, I don't know the numbers now, but I think the idea is we need a lot of land to supply us. So our consumption of everyday life needs a lot of land. And this is a very important perception that we have in mind. Today, we speak of the urban ecological footprint, if we want to grasp this meaning. So which kind of lands or part of lands we need, like fishing grounds or grazing land, croplands, forests, for our living in the city. And behind that, there are a lot of hidden effects. For example, what was shown, so what you see here, maybe better or not, this is just Google Maps. Go to Brazil and have a look at the rainforest there. Rainforest as a, let's say, symbol for biodiversity, and you will see there's a lot of change going on. And this is really also something that is indirectly forced by the cities and our way of living. There's another aspect, and I like this very much. It's not my idea. I'm very angry about that. It's from Professor Frank Schilling. I really like his thinking. What happens with global warming in cities? So what he says, I really like that, is, okay, Denise, if you think of 1.5 or 2 degree warming of the total globe, this is an average. So our Earth contains of 70% water, and this water will just warm up to 1 degree. So our land surface has to warm up even more to get 1.5 or 2, so let's say 4 degrees. And our cities, of course, because of the urban heat island effect, will have a much stronger effect on that, let's say 8 degrees, just to get the idea of what global warming actually means in our cities. And I also really like this study. It's from the ETH Zurich, and they took the 1.5 degree climate scenario, which is what I heard not possible to reach anymore. So they took the lowest scenario here and made city comparisons. Like, okay, if we compare London and Barcelona today, in climate aspects, we have no correlation at all, that's for sure. Okay, so, but what happens if we take London today and London in 2050? And we see this is the yellow line here. It's also not very statistically close to each other. But what we see is if we compare London in 2050 and Barcelona today, there's a strong correlation. So there you can really grasp what it will mean in 30 years for us, or 20-something years, for us to live in our cities. And when I think of Karlsruhe, where I live in, how will that be in 25 years? So they made an average about everything they found. They say it's about roughly 1,000 kilometers south, which will be, and my colleagues from Thessaloniki know what will happen now. It's Thessaloniki today. Well, it was called the Mediterranean effect in this in the session yesterday. So this might sound nicely, but I would like to have the sea as well, please. I don't like only to have the heat and the drought and. Yeah, so no, just kidding a little bit, but I mean, this really means a tremendous effect on our cities and also the surrounding where we live in, our forests and how we do our agriculture, just to go on that. And if you think Thessaloniki 1,000 kilometers south, what is there? And what is there 1,000 kilometers from there? So, and it's just a 1.5 scenario. Yeah. Just to add to all the problems said in the last days. So there are these 2 key aspects that are highly, let's say, recommended from the Research Society, so that we have 2 aspects why cities are key for sustainability and climate change is because they are, on the one side, significant contributors, and on the other side, highly vulnerable to the impacts, not only the warming, but also if you look at extreme events or the rising sea level. So many cities on coastlines farm in the developing countries. But there's also another aspect, which is kind of a more thought that I had, and I want to share it with you. And I like to call it the SUV effect. So 10 years ago, nobody in my neighborhood had an SUV. It just didn't make any sense to have such a huge car with our small parking lots and small streets. And then somehow, I don't know, people bought an SUV, and it was so fancy to have one that now all of my neighbors have SUVs. And this is not I'm not an expert in this, but I mean, there is really research on why do people do things. And let's say it's the neighborhood effect. So my neighbor has it, it seems to be likable, so yeah, I do it. And the good thing is, in cities, we have a lot of neighbors very close to us and close to each other. So I think this is a really effect that we can use for promoting good behavior and to show other ways. So I would hope that it spreads much better in cities than in rural areas to do the good things, let's say. Okay, so I hope why urban research is kind of, I answered that a little bit before. I just want to say something about IPCC working on that in the last, of course, 10 years. They always looked at these urban areas as well, and now they will launch a new special report on climate change and cities. Starting from now on, it will be developed in the next 5 to 7 years. So all the urban research that we conducted so far will go into that. And of course, the research that will be conducted in the next years. So I think that's a great thing that also this research will be combined, which is really complex, but I will come to that. And a second issue, of course, are the SDGs. Cities are part of the SDGs. SDG goal number 11, make cities and human settlements inclusive, safe, resilient, and sustainable. And you can do that by these examples that I have here, and they are not by coincidence in our KIT Karlsruhe, because these are things that are done at KIT. For example, sustainable mobility and transport, reducing environmental impacts and wastes, questions on sustainable construction and renewable energy, also risk management, a CDIM center, climate protection and adaptation. So with that, there's another aspect why urban research, why scientists should do that from my perspective. As you see here, this is from colleagues from us. They thought about what is urban planning doing, and they found that it's a so complex topic to plan cities. And if you go on the research side, of course, you have other aspects, social aspects, and so many aspects to research in a city. And because it's so interdisciplinary and we need so much innovative concepts, I think science is the perfect place to do that. So the last part will be about the platform of urban research at KIT. Also giving you some nice, interesting information, I hope, about the topic as well. So this is not a new topic at KIT. Former colleagues also worked on this and asked themselves, okay, we are a lot of people doing urban research, but we don't do it together at the moment, and we should do it. We want to do that. And some years ago, they produced this as topics that we already research at KIT, like the urban system, the quality of life, resources, infrastructures, risks, and plan and design. And if we look at this today, we have to exaggerate that. It's even much more, but I will come to that soon. So for you, those of you who are not KIT members, just to show you a little bit the whole institute. So KIT Urban Research is not for one institute or for one division. It's for everything. It should cover everything that we do at the whole KIT. So we have 5 divisions, and some are working more or less on this topic. And I guess the most, the focus is on the Division 4, Natural and Built Environment, where also my boss, Johannes Orphal, is working. And yeah, so I'm working with him now on this topic as an officer of urban research to help them, or help this, to build up this platform. And beside this, because we are one side university and one side Helmholtz, we have this special situation that we have divisions, and also that we cluster topics in centers. So we have several centers on several topics, and all these centers that I have here, there are some more, also working on urban research. So we have a lot of people doing a lot of urban research, and this has to come together somehow. As I just said, so going now down a little bit more in detail, we have some units like the Climate Bureau. You maybe have heard talks about that. They're working on climate mitigation, also the Karlsruhe Transformation Center. So they work with the citizens, with companies on how to mitigate climate change, and OICOR, of course, working with the students. So there are a lot of units that are already working on this topic, and of course we have a lot of projects that are facing things like what I just said, mobility, energy, sustainable housing, and all these things. So to give you just some short examples, on the left side, there you have a project. This is from Professor Hebel, architecture, and he and his students, they won a competition of the sorry, I don't have my notes. European, so it was an international competition, and they won this because they made this rooftop. It's very from just sustainable materials. So when we were saying in the beginning of my presentation, we will have a lot of more people living in cities, and they need housing. And we also don't want to lose our forests and our green spaces. So what can we do? And this is one solution. So go on the rooftops and use sustainable materials to build up new housing. So this on the left side. Or the other colleagues working on mobility transition. They also take an agent-based model. This is for Hamburg, and ask, so how can we help the people to take up a better mobility? And of course, working with citizens in real labs. I think the real lab thing was kind of born in Karlsruhe, or has a very focus on Karlsruhe, and of course on the total urban system. But this is just a part, as you will see. I want to define today, there are some more, 3 main goals that we have for this platform. It's on the one side, we want to strengthen interdisciplinary collaborations, because we see that we need to interact more with each other. This was a conclusion in many talks in the last days for sustainable development. The second goal is to strengthen the visibility of the things that we already do as an entity under the umbrella of KIT Urban Research. And of course, the third goal is the transfer to municipalities, cities, to citizens, and to companies alike. Going to goal number 1, strengthen the interdisciplinary collaborations. What you see here is just a word cloud of the research fields that we have at KIT, not exclusively, sorry if I missed something. What we do, so we do a lot. And as you see, it's now standing side by side and not really interconnected. And a working group on a strategy at KIT developed the idea to categorize it, to better sorted in lines so that the research can be better transferred and also research gaps can be identified. To strengthen the interdisciplinary collaborations. Goal number 2 is strengthen the visibility. So why should we do that? Are we as good as other universities? Is KIT able to say we do urban research and we are not, I don't know, number 30 in Germany? And what you see here on the list are universities of applied sciences and non-university research institutions of Germany. And working group from Professor Barbara Engel at the Institute for Urban Landscape and Design made an evaluation of the research output in these areas here, always connected to cities, energy, mobility, water, urban ecology, digitalization, and compared the research output at several universities at the same time span, and they found that KIT is on the 3rd place in Germany, just right behind TU Berlin and TU München in this urban aspect. So we really should make it more visible to the outside what we already do and then go forward. This is, of course, only possible because a lot of institutes, just abbreviations here on the left side, working on that, and a lot of people already do these things also in other units. Like here in the Center for Climate and Environment, we had this workshop this year. Okay, coming to something that is only on my desk is the new homepage that will be released soon. And this combines all these goals that I showed you before, like public visibility, but also creating a database and search for projects and partners inside the KIT, so that our professors will find, or researchers will find easier other collaborators inside KIT, but also outside for internal networking, information for students, of course, and also contact to cities and companies. And this is my 3rd point. I think strengthen the transfer to cities, municipalities is very important. So what we also do is giving speeches on conferences where only municipality members and politicians go and show them what we do. And on the other side, of course, we also do inter- and transdisciplinary projects directly with cities in every institute, or in so many institutes. So this is the work of many, many people. I just want to close something because I'm also a researcher, not only and urban officer for urban research. So my research is mainly interested in warming of cities, urban heat island, and the climate adaptation. And we had, so going to the goal of transfer, we were helping a city to adapt the new city quarters of 20 hectares to climate change. And on the other side, so for them we were experts, but on the same side we had kind of a social study going, using participant observation, which is an ethnological way of looking at what is going wrong in this case. So why does it not, does climate adaptation not really drives well in municipalities at the moment? And what we found in this is that 75% of the problems that were faced by the members there in this municipality were system immanent problems. And this was not what the people said to us. I was working there 1 to 2 days for 1.5 years, so I observed that it's not biased in what they want us to know, but what we really saw, that they are always not able to do what they want and how much that they want, because they need more help from politicians, also from scientists, more data to prove that they have to do something, and that what they want to do at this place when they want to build, that it will really help in the future. So I will close my talk by showing you this. This is also, for me, a very important statement that I want to make. The city of Düsseldorf promotes this as a very elegant and really cool solution for climate change adaptation. So just take a building, put on 30,000 trees, and then you have a very climate-proof building. Just saying that this building is irrigated by groundwater. So I'm not sure if this is a sustainable way to use your groundwater to have one building cool down a little bit. And so coming to my last slide, just saying also science sometimes have to say that things are maybe not the best idea, and maybe things that we already know are the best idea. So it's not only about innovative, it's about really knowing what will help and what is sustainable and really saying that. And I had heard so many talks in the last days, so I'm really happy that so many people work on this, and I'm very sure that we can make that. So with that, I want to close my talk, say thank you for all your efforts in making sustainable research and also communicating that, and thank you for listening. Thank you.
Yeah, thank you very much, Denise, for this really, let me say, holistic overview of what's going on in KIT and the possibilities. Are there questions or comments or explanations, additional remarks? Yes, please.
Yes, thank you very much for this very nice overview. Yeah, I have the feeling also from your last example that we somehow lag behind the need with regard to our planning processes and also to our adaptation processes. So the need to adapt and to have more sustainable planning is really very important. But what can we do to support communities to make, to help them to be a little bit faster?
Help them to be a little bit faster. The people, when I talk to them, sometimes they say, can you help us at KIT, please? We have to do that and that. And then I always have to say, yeah, this would be very nice, but there's the problem that we need money and that we have to get somewhere there. So I think one thing that is a problem from a science perspective is that we have the wrong goals at the moment. So we are measured with the wrong instruments for our output. I mean, just from a research perspective, that's good, but not from a, let's say, transformative perspective, and that we really do transfer outside. We really need more instruments and measures to kind of make this visible, that people do that. So from the scientific side, and yeah. I think we have a real system immanent problems that are very complicated to solve. But sometimes they just want to have easy to implement answers. So what should we do? What measure? So also what the Southern Climate Bureau is working on. They just ask which measure should we do first to get our goals. These are simple answers that they need to go further and implement their mitigation, adaptations, measures. Yeah.
Yeah.
And numbers.
Yes, please.
Thanks for your talk. Maybe just a comment. I also realized still a strong focus maybe in research areas on Europe, but if you think about 2050 and 80% of people living in urban centers is mainly in Asia, mainly in Africa. So I think also a lot of projects and focus should also be in those regions, because they probably have way less capacities to adapt, and whether we live here in a Mediterranean climate or not, and like it or not, it's maybe doable, but in those regions it's much more severe.
That's true. It's more for the German society, the talk, and of course, you're right.
Please.
I have two questions. The first one, this is in my opinion. If we were not living in urban areas, there would be less areas for wildlife. Do you agree? And the second one is a question. You said that cities need much more land than they are placed now, and this is due to which needs of humans? I mean, food, transportation, which needs is requiring that much land in cities for the people living in cities?
You mean the 200 to 1,000?
Yes.
I think, okay. So the first question was, okay, so would it be better if everyone would just live somewhere? I mean, of course, it's a, I don't know, I don't know, I mean, the question is kind of, yeah.
We are 8 billion in total in the world.
Yeah.
So if we were living in rural areas, this means we are occupying much more land that we are taking in.
Yeah,
that
I hope I didn't
urban.
give the impression that I think that we should not live in cities. I think it's a good way to do it. It's just more, I mean, you can improve it, let's say, also what you, what you consume. So this is leading to the next question. So I think this is a long story. When you look at the urban footprint or carbon footprint, there are lots of things going inside. So everything that you consume has a long footprint and cycle. We had so much talks about that. So everything that you do has a lot of impact on the one side, and if you waste it on the other side. And I think they had a lot of forest there, so I thought they will have included the CO2. But I don't know the details of what they did. But you can read it in every urban footprint, and you can also measure that. And cities do that. Hamburg did it, for example, or Berlin. Yeah. So, but everybody does it in a slightly different way. So, yeah.
Yes, please.
Yeah. Oops. Yeah.
Maybe I can contribute a little. So basically, when we look at these cities, we have this one side which you presented, which is, okay, people in cities will be vulnerable, etc., and we really need to address that. On the other hand, cities have an impact. But this idea of cities having an impact, that's basically humans having an impact. Also, those people living in the countryside will have very similar footprints to individual humans living in the cities. However, we can, of course, sometimes see some effects, for instance, like increased levels of, well, let's say, SUV consumption, which are quite characteristic to certain urban lifestyles. And so we can basically compare different lifestyles depending on the region where people live, and from these calculate the footprints.
But there's also an additional effect. Actually, people in cities are in average richer and consume much more than people on the rural side. So we really have also a shift, not only in this is why you have 57% of people living there, but 80% of consumption. So there's a real, we consume a lot more in cities than in the rural side.
And with
depending on,
And with that, I would like to thank Denise again for this contribution.
Thank you.
I officially close this scientific session, and I give the mic back to the chief operator, the chairman of the symposium. Johannes, please.
Thank you for the session, Kavi. Thank you again for all speakers. Yeah, I want to close this conference now, but I have actually a song of Stevie Wonder in my ear, if you know, Living It Up for the City. And if you don't know it, it's 50 years old now. That was in 1973. So when you go home, just maybe you want to listen to it. Stevie Wonder is just great. And the last lyrics is, I hope you hear inside my voice of sorrow, and that it motivates you to make a better tomorrow. If we don't change, the world will soon be over. Living just enough, stop giving just enough for the city. I will not sing it, but you know, just think about it. This conference was an experiment. It was the first of its kind, I said it on the first day, because it's very broad. It brought together also lots of different experts. It was very diverse. We had people from many disciplines, and we were not sure whether it would work out in the end. And we will make a little questionnaire to you, and you can answer that. And you can also answer other things like whether you like the food or whether you like the building and so on. So just don't be surprised, we'll ask you. But my impression was that the experiment worked out quite well. If I just look at this last session here, where we looked at the solutions, and you know, it's challenges and solutions to transform to the sustainable future. But we have heard about the cities, about land use, about critical infrastructure, about the change of the energy system. And I said on the first day, you will certainly hear things that you don't understand or where you thought you would not understand. And this is exactly what the purpose of the conference was, that we learn from each other, that we know about the complexity, and that we gain confidence and hope that we can do that. And I think that was indeed a success. All the lectures that we had in the plenary here have been recorded and will be available on YouTube, and we will send you the link. And so please make sure that people can see that, hear that, they can learn. You know, that's so important. I think that's the most important thing that we can do as scientists, that we can learn from each other and transport it to other people. So please do that. And now I want to close with thanking, first of all, the people on the technical side who made this possible, which are the technicians there. Give them an applause, please. That was just fantastic. The same is true for Isabel Windbiel and her team. I cannot see her, but she did all the organization, including this fantastic dinner we had in the ZKM, if you remember. It was actually, from that perspective, also the best conference I ever have seen, because it was just perfect. So give her an applause, please. And I also would like to thank the local organizing committee, in particular Kirsten Henrich, Tina Kunz-Plapp, Isabel Windbiel, Jennifer Hertenstein, Clara Langer, and others, and the scientific steering committee from the University, from Epicure, and in particular Thessaloniki, who really helped us to establish this interesting program. We are seriously thinking about repeating this experiment again in 2 years in another University, maybe Strasbourg, maybe Freiburg, maybe Basel, maybe Mulhouse. We don't know yet, but so please save the date already, that in 25, in October, it will not be in a science week, but we will have a sustainability conference probably again somewhere here in the Upper Rhine area. And last but not least, I would like to thank you for coming here, for actively participating, for all your contributions, and for carrying the spirit of this conference along also to the outside. Thanks very much, and I close this conference now. And lunch is ready.